Imagine pointing a radio telescope at what should be an empty, silent patch of sky, only to hear something that behaves with such precision and structure that it instantly raises every red flag in modern astrophysics. No star, no planet, no neutron star, no black hole is supposed to create a transmission this stable. Yet here it is, a repeating sequence of pulses so mathematically perfect that the first reaction from astronomers wasn't excitement, but disbelief. At first, the team assumed the equipment was malfunctioning. Signals this controlled simply don't appear from deep space, especially not from regions with no known active objects. But when the same pattern showed up in multiple observatories across different continents, one thing became clear. This wasn't interference, and it wasn't noise. It was real, and it wasn't stopping. The pulses arrived in absolute rhythm, not drifting, not wobbling, not showing the typical signatures of a natural astrophysical source losing energy over time. Even pulsars, the most reliable cosmic clocks, gradually changed their rotation rate. But this signal? It held perfect time, cycle after cycle, as if driven by a mechanism designed to remain unwavering across millions of kilometers of travel. The structure of each pulse added even more confusion. Instead of a smooth spectrum, the signal split into evenly spaced peaks, like the teeth of a comb. In radio engineering, this kind of pattern usually means intentional modulation, something shaped deliberately, not produced by turbulence or magnetic chaos. Yet the region the signal comes from contains no known neutron stars, no magnetars, no interacting binaries, nothing with the power or behavior to create such order. And then came the strangest detail. The pulse brightness didn't vary randomly. It jumped between a few fixed levels, almost like preset transmission modes. That kind of step behavior simply doesn't happen in nature. Whatever is producing this signal is following rules we don't recognize, or rules our current physics can't describe. As more data poured in, astronomers tried everything to force the signal into our existing models. Could it be an ultra-slow pulsar behaving in a way we've never seen? No. The spectrum was wrong. Could it be a magnetar flare repeating in some unusual resonance? The energy output didn't match, and the timing was far too clean. Maybe a black hole's jet modulating radiation in a periodic cycle. Black hole jets are violently unstable, nothing like the calm, clock-like stability observed here. Even exotic theories struggled. Cosmic strings, hypothetical cracks in space-time, can release bursts of radiation, but they don't repeat with perfect precision. Dark matter interactions? Possible, but the signal structure looks engineered, not chaotic. With each eliminated explanation, the anomaly grew stranger. The pulses weren't just regular, they were synchronized to a degree that seemed impossible across astronomical distances. Imagine a lighthouse beam that never flickers, never drifts, and keeps its brightness transitions like a machine switching gears. Natural objects simply don't behave this way. But then researchers noticed something even more unnerving. The timing of the signal subtly shifted depending on Earth's motion. Not because the source was unstable, but because the signal was so precise that even Earth's orbit introduced detectable variations. That meant two things. The source is extremely far away, and whatever generates the signal maintains its structure across that vast distance without degrading. In astrophysics, everything smears out over time. Gas clouds scatter light, gravitational lenses distort it, plasma fields shift radio waves. But this transmission held together perfectly, almost as if it were designed to resist the universe's interference. The team began running simulations, trying to craft any natural scenario that could mimic what they were seeing. None worked convincingly. Instead of behaving like a star or a magnetar, the signal behaved like a beacon, something transmitting intentionally, consistently, and without failure. That doesn't mean it's artificial, but it does mean that whatever produces it is governed by physics that doesn't match our textbooks. And that is where the real mystery begins. To understand just how strange this is, you need to know how finely tuned cosmic processes normally are. Even the most powerful neutron stars gradually lose rotational speed. Even stable binaries drift in timing. Even pulsars, the universe's precision masters, show glitches, micro-variations, or jitter caused by their intense magnetic fields. But this signal? Nothing. No drift, no glitches, no decay. It repeats with a consistency that seems engineered. The spacing of the pulses even suggests a mathematical sequence, almost like harmonic frequencies layered on top of each other. When astronomers plotted the data in 3 dimensions, frequency, time, and intensity, the signal formed a geometric pattern no astrophysical object is known to produce. One researcher described it as too perfect to be natural, too powerful to be artificial. And that paradox is at the heart of the mystery. One emerging hypothesis suggests the signal may come from a resonance phenomenon involving particles or fields we haven't discovered yet, something interacting with space-time itself to preserve coherence across unimaginable distances. Imagine a wave traveling not through space, but through the underlying structure of the universe. Another idea proposes that the source might be embedded in a dense pocket of dark matter, where exotic physics could amplify or stabilize the pulses. But the boldest idea is the one that scientists mention quietly, cautiously. What if the signal is not a broadcast, but a byproduct? Not a message, but the hum of a megastructure or astrophysical engine operating on scales far beyond our technology. In that case, the transmission might be accidental, a leak of energy from something immense and ancient. Still, astronomers avoid jumping to these conclusions. History has shown that nature often surprises us with phenomena we couldn't predict. Yet this anomaly stands apart, more structured than FRBs, more precise than pulsars, more persistent than magnetars. And with every observation, the puzzle deepens. Then, just when researchers thought they understood the pattern, everything changed. After weeks of identical pulses, the signal shifted. Not randomly, but in a way that implied recalibration. The timing tightened, the spectral pattern sharpened, and the brightness levels adjusted, as if the source had entered a new operational state. Natural systems don't do that, but systems governed by feedback mechanisms, machines, reactors, engines, do. Again, that doesn't prove anything artificial, but it raises questions no one can easily dismiss. Telescopes across the world began coordinated observations, hoping for a counterpart in other wavelengths. X-ray detectors found nothing. Infrared sensors found nothing. But in extremely low-frequency radio bands, analysts detected faint sidebands, echoes or harmonics, hinting at an astonishing possibility. The signal may not originate from one object, but from interference between multiple sources acting in sync. This opens a new branch of theories involving gravitational resonators, quantum-scale fields, or even space-time cavities where waves reinforce each other. If true, we may be witnessing a type of physics that operates outside of our current models, a phenomenon that doesn't break the laws of nature, but expands them. And that's why this discovery matters. Whether the source is a new type of compact object, a dark matter-induced oscillation, or something entirely beyond our imagination, it forces us to confront the limits of human understanding. It's rare that astronomy sees a signal so clean, so persistent, and so fundamentally incompatible with everything we know. It could take years of observations, new telescopes like the SKA, and breakthroughs in theoretical physics before we begin to understand it. But one thing is certain. Somewhere out there, something is producing a signal that shouldn't exist, and it's still pulsing, waiting for us to decode it.